This is called the triangle method. So what we're going to do is we're going to take a system in 3 variables like this, and we're going to create a matrix. So I'll go ahead and do that first before we start talking about what we're going to do and how we're going to do it and why we want to do it. I'm going to take all the coefficients of my x, y's, and z's and just write them down here in a grid in a matrix. So 5, -2, -3, and then the 16. 2, 3, -2, -2, 3, -1, -6, 5. Okay, that's a 3 by 4 matrix. I'm going to put a little line in here just to indicate to myself that that last column is where the answers lie. And I'm going to label these rows. I'll just call this A, B, and C. Okay, there I have it. Now, let's talk about our goals before we talk about our methods. So our goal is going to be to take this matrix, and we're going to kind of rejigger it so that there is this triangle of zeros down in the lower left-hand corner and another triangle of zeros in the upper right-hand corner. So all 6 of those numbers that I just highlighted are going to become 0. Okay, we're going to turn them into 0. We're going to follow some rules, some steps to do that. And then I'm also going to, and this will really be helpful to me, I'm also going to turn the remaining 3 numbers there, that diagonal set of numbers going down, 5, 3, and -6, I'm going to turn those all into 1s. Now, if I do that, when I accomplish that, then this fourth column here, that 16, -2, 5 that I set aside, that column will contain the answers to the system. It will be what x, y, and z equal. Okay, so that's going to be really cool. It's a bit of a process, but the nice thing about the process is it only takes adding and subtracting and multiplying and a little bit of dividing. Okay, here we go. There's only 2 rules. Rule number 1. I can take any row and just multiply the entire row by a constant, or divide, at any time. I can do this any time. So if I think that it would be useful, let's say for that 3 there to be maybe a 6, I want to make that into a 6, so the only rule is I have to multiply the 3, the -1, the -6, and the 5 all by the same number to accomplish that goal, which would be 2, so multiply everything by 2 in that row, and that's a perfectly legitimate legal thing to do. Alright, that's rule number 1. Rule number 2, I can take 2 rows and combine them together by addition, just add them together, or subtracting. And then take the answer, whatever I get as the answer, and replace one of those rows with that answer, that set of answers. Okay, so let's do that. I'm going to go ahead and pick that 3 that I put a box around. I want to make that into a 0. And to do that, I'm going to kind of take a look at all my rows, and I'm going to say, okay, I'm going to add that 3 to something else and get 0. It would need to be a -3. I don't have one, but if I took the 2 there and the 3 there, I could change both of them into something that would cancel fairly easily. That is, if I took the B row and I multiplied it times 3, and I took the C row and I multiplied it times 2, then that would come close to canceling. I'd have a 6 in both of the first positions there, but I need one of them to be negative, so I'm going to say negative or minus 2c. So I'm going to do that, and then I'll replace. I'm going to take whatever I could get out of there. I'm going to put that in the new C row. So I'll call it C1 to differentiate it from the original C. Okay, we'll see about that in just a minute. Let's do these steps. So 3 times the B row. So I've got the B row there. I'm going to multiply everything by 3. So 2 times 3 is 6. 3 times 3 is 9. -2 times 3 is -6. And then another -6. And then I'm going to take the C row and multiply it by -2. So Negative 2 times 3 is negative 6. Negative 2 times negative 1 is 2. Negative 2 times negative 6 is 12. And negative 2 times 5 is negative 10. I'm going to add those together. 6 plus negative 6 is 0. 9 plus 2 is 11. Negative 6 plus 12 is 6. And negative 6 minus 10 is negative 16. Okay, well, I did that. Who cares? What for? What was the purpose of that? Well, I said I'm going to replace the C row with that, and instead of actually erasing my C row, I'm just going to create a new one here. I'll call this matrix 1 to differentiate it from the first matrix, C1, and that row is going to be 0, 11, 6, negative 16. Now, if I do that, it kind of implies that I also need to get a new B row and a new A row, and that's exactly what I'm going to do. So let's focus on getting a new B row, and I'm going to have the same goal for my new B row. I want to get rid of the first number there. So currently my B row is 2, 3, negative 2, negative 2. I want that first number to be 0. Now, think about this logically. I could do exactly the same steps I just did before, combining the B and the C rows together. And if I did that and canceled out that first number, I would end up with the exact same row, the same line I just used, that 0, 11, 6, negative 16, which would not be helpful because that's like saying the same line twice. So I need to get a different set of numbers there, but still have a 0 in that first term, and so I have to use the A row and the B row instead of the B and the C row. So I'm going to think about a way to cancel out the 2 with the 5 above it, and if I multiply the A row times 2 and the B row times 5, and then again make one of those positive, one of those negatives, that will give me what I want. That 2 will become a 0, and I'll just slide that in as my new B row. Okay, there's the plan. Let's do it. Okay, so 2 times A, 2 times 5 is 10, 2 times negative 2 is negative 4, 2 times negative 3 is negative 6, 2 times 16 is 32, then negative 5 times the B row, negative 5 times 2 is negative 10, negative 5 times 3 is negative 15, negative 5 times negative 2 is 10, and negative 2, 10 again. Add these up, we get 0, negative 19, 4, and 42. So we'll write those in. 0, negative 19, 4, and 42. Okay, now I've been focusing on the kind of the lower left-hand corner. I got rid of the 3 and I got rid of that 2. I have everything I need to do to get rid of that negative 1, but I'm going to kind of save myself time later on. I'm going to get a new A row, and I'm going to focus in on getting rid of the 3, the negative 3 there. And to do that, I think what makes most sense to me is if I think about, well, negative 6, you just have to multiply negative 3 times 2 and we'll get negative 6, but of course we want it to be positive 6, so let's do 2 times the A row and then maybe multiply the B row by negative 1 so that those will cancel out nicely. Okay, let's try it. So 2 times the A row minus the B row. Oops. I said B, I meant to say C. E is going to be my new A row, A1. see if that works. Okay, 2 times the A row, that's 2 times 5 is 10, minus 4, minus 6, and positive 32 again. Multiply the C row by negative 1, so negative 3, 1, 6, and negative 5. We'll combine those, we get 7, negative 3, 0, and I think that's 27. 7, negative 3, 0, 27. Okay. Now I have completed all 3 rows. I have a brand new matrix. And notice that my new matrix is a lot closer to my goal than my old one is. My goal is to get these little triangles of zeros here. Oops. And here. And you can see out of the 6, what I wanted to be zeros, I have 3. So that's pretty good. So let's do it again with this new matrix. Gotta keep following the same rules. And I have to warn you, we're kind of at the difficult spot. Okay, not going to do anything different. This is kind of where, at least on this problem, this whole process gets to be really tedious. Because I'm going to focus in on getting rid of this 11, making that into 0. In order to do that, I'm going to add the C1 row with the B1 row and cancel out that number there. And to do that, I'm going to end up having to multiply by some really big numbers, right? I have to multiply the B row by 11 and the C row by 19. And that will create my new C row. That will be C2, which we'll set that one up in just a minute. But that means I'm going to have to do some really significant calculation work here. So get out your calculator. Don't be afraid to use your calculator. Be sure and use your calculator. This is not the time to be proud about this. I'm definitely not. So 11 times the B row. 11 times 0 is 0. 11 times negative 19 is negative 209. 11 times 4 is 44. And 11 times 42 is 462. Okay, now we'll do 19 times the C row, C1. That's 19 times 0 is 0. 19 times 11 is 209. 19 times 6 is 114. And 19 times negative 16 is negative 304. Now we add 0 plus 0 is 0, negative 209 plus 209 is 0, 114 plus 44 is 158, and 462 minus 304 is also 158. Now that's significant, because remember we said that at any time I can come along here and multiply a row or divide a row by the same constant number. At any time it's convenient, and here it's really convenient if I divide by 158. So I'm just going to divide each of those by 158, and I'll get 0, 0, 1, 1. And that is so much nicer than the rows I was getting earlier. Let's fill that in. 0, 0, 1, 1. This will be my new matrix with a C row there, a B row, and an A row. Okay, so we're going to fill this one in, and this will be it. We'll be done here. Draw the red line there. Okay, so we're ready to go. Unfortunately, we're out of time for this recording. I have a 15-minute limit, so I'm going to stop the recording, and then I'll start a new one. Please jump over and watch that one, and we'll finish this one off. Thanks for watching. Okay, we're back. We're going to finish this one off. Please, if you have not watched the first half of this recording, this will make no sense. Go back and watch the first half immediately before you